Okay, I'm showing 12 o'clock noon Eastern, so I'd like to get started. I'd like to thank everybody for calling in to this first BIM session under IBIU. There is a series of 13 sessions that we'll be holding over probably the course of the coming year. And this first one is to look at Introduction and Fundamentals when it comes to building information modeling. A reminder, as part of IBIU, all of the courses offered are AIA accredited and thus will qualify for one learning unit whether you reside within Canada, United States, or the UK. If you're an AIA member, please, when you're signing in, provide your AIA number over to your local office coordinator, and the points or the learning unit will be added to your AIA records. And if you're not an AIA member, certificates will be issued from IBIU, which you can then use as the backup documentation for logging this as a directed or structured learning opportunity. So this course, we're going to look at BIM and how it applies to the AEC industry, that's architecture, engineering, and construction. We'll look to address some of the myths which surround BIM and outline some of the fundamental principles associated to BIM. The learning objectives introduce the concept of BIM as a mode of delivery, as I said, addressing the myths, describing some of the resources available, and enforce that BIM can apply to all disciplines throughout a life cycle and how critical it is to plan and execute. Once we lay this as a foundation, this will then form kind of the concepts for the subsequent seminars that will delve deeper into BIM itself. So the introduction of BIM. Always, of course, we've got to start with a definition. And of course, BIM being as complex as it is, there isn't just one definition. There's BIM the noun and BIM the verb. So building information modeling is the process of generating and managing a digital representation of physical or functional characteristics of places. And I use places strategically there because it's not just an object, it's not just something in a building, it's not just something sitting on a site, but it's the interconnectivity of them all, how they interact with the ecosystems and the infrastructure that supports those objects. BIM the noun are the files where information is exchanged and networking occurs that supports decision making. BIM software can be used by individuals, businesses, governments, etc. for buildings, infrastructure, you name it. And it can be applied whether it's a building, an infrastructure, or a system, the I, the B, or the I. So it's interesting, keep that in the context that the application of BIM really can apply in any one of our sectors. Collaboration and planning, although not specific in the definition, are probably the most critical things. You've got to plan what you're doing, so that's an undertone of this entire presentation, and we need to collaborate. And that could be collaboration with the person sitting right beside you or somebody sitting on the other side of the world. Still collaborating, still got to speak, and you still have to exchange information. BIM is not unique to our industry. So what I'm showing here is BIM used in the medical profession. And this is actually a digital model taken of my son who had to have surgery on his skull, and it was a before and after. So they analyzed through CT scans, they portrayed what the issues were, they did before and after comparative results, and it was all done through 3D. And of course, me being the BIM guy, I said, can I have the model? And they gave me the model, which is pretty cool. BIM in a museum. Last time I was at the British Museum, I was just walking through and I was fascinated by this individual in front of me who was cutting a section through a 3D model of the Gabeline man. And I said, how amazing is that, right? BIM in practice, everybody was interacting with this computer screen, but I don't think anybody was actually realizing that it was BIM. It was a model with information. They were sectioning it. You press one of those info markers, it brought up data about the portion of the body that you clicked on. Very BIM. Back into our industry, BIM is boiled down for me, geometry plus some data. And the geometry plus data is what makes it BIM. Now, it's not just buildings, but there's a building example. But on the top left, it's the typical blob, the blob of whatever exists on any one project. The fact that you're modeling a 3D characteristic of it, and it's taking up virtual space, and it's going to have some information, and that information is going to be conveyed back to us. The example here, it's a condensing unit, it's a mechanical unit, and it can have a whole host of information filled out, or it can be nothing more than just knowing that it's a piece of a mechanical equipment. And all of that scalability of the scope of application is catered unique to any one specific project. In the civil side, from the macro to the micro, so BIM applies with linear infrastructure in a similar manner, but it takes more into context the geographic information system and the layers of data that exist. And then it looks to say, well, that curb, yes, it's a curb. It'll have materiality, so it's made of steel. It'll have some connection points, and it'll interact with the ground. But it's a micro element on more of a macro system, being the bridge, which is part of an overall road, which is part of a complex network. So that interactivity of macro to micro is also a huge part of what makes BIM happen. So when we're looking specifically at buildings, BIM is this multidisciplinary collection of data. It's all of the assets and the components that reside within the building. This is an electrical model, taking up the same virtual space as a mechanical model, as a structural model, as the architectural model. All of these disciplines come together, form a single combined whole, which you can then interact with. You can slice and dice. You can create sections. You can take material quantities. Some material quantities, it's as simple as saying, just tabulate what's in my model. And if I'm using a good BIM authoring tool, that material quantity is pretty robust. And I hate saying push button, but it's almost push button. You can check for interferences. Do I have ducts that are hitting the beam? If so, BIM's not going to fix it, but it should quickly inform to a structural and mechanical engineer that something's got to give right there, because that can't work. Simple communication tool. You can also get plans and sections and schematics and rendering views, isometrics, etc. All of that is a byproduct of the fact that there is a model behind the scenes. And all of this is kind of what I like to refer to as the typical BIM. If we're doing BIM, you're going to get this. The degree of how well you get it is probably dependent on how well the model is, and dependent on project delivery factors of change control and schedule and budget and all those good things. But there's more to just BIM. Looking at the civil side. So civil, you get your drawings, but you can get plan and profile. Plan and profile is a huge concept where you can go along any alignment, and it will tell you the elevation, its relationship to the adjacent components, and how it will change throughout the course of that alignment. And it's auto-generated as well, depending on the authoring tool that's being used. You can still look at virtual built form. Here it's more about the interferences and the interactions of components and the free space or the reserved space to run forklifts along this pier. You can have drainage utilities, underground utilities. Every single building is going to sit on a site and be connected to a whole network of utilities and etc. You can have linear infrastructure, existing, transposed with new, transposed with the surfaces. Civil colleagues of mine love to point out that the building is the little piece in the middle and the civil is everything around. But it's all BIM. It's all part of the overall infrastructure network that comes together. Roadway interchanges takes up so much of our space and infrastructure, it's unbelievable. Roundabout designs, rail networks, laser scanning of existing space. So there's a lot of potential there from a civil-focused BIM perspective. Then there's plant. Plant is the other aspect of BIM where you may not only have built virtual form, but you could also have a schematic underlay that feeds built virtual form. So this is an example of a typical plant schematic, and why I like to show this is it's as much BIM as a building model would be. The idea here is the schematic you're seeing there, the collection of valves and other components, they could be across a massive treatment plant. Yet when focused in a schematic like this, you can simply see that, query the schematic, understand the number of assets that exist, interact with them, feed them to a database, and do who knows what with them. And by the way, this also links to the actual typical 3D model that you may be used to seeing. So if I know that I have 100 pieces of equipment, those 100 pieces of equipment will be compared against the model. And if my 3D model has 101 pieces, I'll be able to know that I have a disconnect. So some powerful tools that exist on the plant or the industrial side of BIM. Then there's the life cycle aspect. So let's say you merge together all of those building, civil, and plant, and you start to build this model up together. You can have a component that starts with a unique identifier. That's all I need to bring uniqueness to my BIM model and then link it to other aspects. And this is the hardest part of BIM, because oftentimes people will look at this and say, well, you know what, if I need all my information, I've got to find a spot for it here in this 3D world. But instead, all of this information is going to be acquired at different stages throughout the life cycle of a project. So that one unique identifier starts to link it to other bits of information, whether they're shop drawings, specifications, operation and maintenance material, operation screens, so the SCADA screens. We do a lot of SCADA work here in IBI, and it can all be related back to the actual model itself. So we can now have this interactive nature between what I'm seeing in the 3D world and all the information procured and obtained throughout the life cycle of the project. It can all come together. If you employ items like an RFID tag, that's a whole other aspect which would then geospatially locate the physical location in the actual built world as well, all connected via the unique identifier. So there's a lot of stuff that can happen, and as you can imagine, it doesn't happen on all projects, and where we would be doing stuff like this, you need a good deal of planning, leadership, and coordination. But to step back, I like starting the presentation with, here's a whole bunch of things we can do. Now, to conceive, I like to compare this to thinking about BIM as a cookbook. And I'll look and say, well, we all understand food. So these are just some images from Google. Think of a cookbook. All a cookbook is a bunch of ingredients that are cooked together via various recipes. And that's what BIM is to me. Get a bunch of recipes and you start to make a recipe book. And recipes can be good, bad, tasty, successful, failure, difficult. And when you look at the history of BIM, there are projects where you'll say that was awesome and we would do that again whenever we have the opportunity. That's your good recipe. And there's other projects that are challenging and we may not have made as much money as we wanted and maybe we even lost money. That would be your bad recipe. The ones you wouldn't want to do again are the ones that would wave the risk flag if you had to do them again. And that's kind of what BIM is. And I like the recipe concept because it's all the ingredients and how they come together. And it's everything from software to people, etc. So when I'm making my BIM recipe, I like to come back to the BIM uses. And I'll say, well, why would I BIM? That's the first thing when I'm looking. I haven't talked about software yet, but what would be the purpose for doing BIM? And we've kind of rationalized them to these set of base uses. If there's no driving factors other than the fact that we want to progress and start to harness this type of technology, these are some of the things that we would do. And BIM, to make my drawings, is the most common. We're bound by that as a contractual deliverable, so therefore we have to do that. If we can't do that, it will fail. And then because we have a model, by very nature, you'll probably want to drive through it and have a look and create some visualizations with the model as a base for potentially artistic visualizations or quick and simple ones. That's great. Then there's other typical BIM uses. When you read all the magazines and you listen to hear the contractors, clash detection, cost estimating, schedule simulation, specs, maybe linking the model to an analytical software. So to prove sustainability or lighting analysis or structural analysis. So they could be design orientated, maybe they're construction orientated. But there's other purposes that could be used. And then there's a whole bunch of other ones that could be considered. And they go on and on. The next course will actually go around this wheel and talk a little bit about each of these. We don't have the time today, but there's some of them, and I just want to leave a tidbit of information here. Imagine we had a project where I said we're going to take our model, feed it directly to a fabricator to produce material to place on site. Sounds very scary, very risky, because what if the model's not good? What are you going to fabricate? What could it be? So I've seen examples where we've taken a steel model, gone through steel production software, fabrication software, and then steel beams or columns are actually produced directly from the model, shipped to site and erected. It's possible, but there's a lot of things in that process that have to be right in order to make it work. The other one, operations and asset management. That's huge. And I like to raise that here because if you're not an architect or an engineer or a contractor, BIM is all about that. Everything else around there is to make the AEC industry, in theory, more efficient and better. But operations, asset management, that's where the owners come in. They go to all the software vendors, they hear about this BIM stuff, then they go back to their fully operable plants or buildings and say, hey, what can we do? What's our management system? What information do I have? And how can I package this, give this to a designer as the basis to start their work? And it's a whole different perspective when they start to say, and as they work, what can I get back that will better the operations of my building here today? So they're looking at BIM from that complete perspective because that's their into the environment. And then from our perspectives, we would have to take that and adapt accordingly. And interestingly, in the last survey that was done, the number of owners, this is the McGraw-Hill survey, the number of owners that are proclaiming themselves as BIM aware is definitely increasing over the last 5 years. And we'll see more of that stuff appear in our RFPs. So if we know what we're going to BIM and why we would do it, then we've got to look at all of these factors that come into play. And I like showing this pie because I would argue that all of them are equally as important. So it's not just my training, because that comes up a lot. We need training. Train me on Revit, train me on MicroStation, train me on ProjectWise, train me on Civil 3D. Yeah, you got to use the software, but that's only a small piece of the pie. The awareness piece is knowing what it's all about, what it could be used for downstream. If I put something in my model today, am I putting IBI at risk because of a promise made in a service agreement for potential downstream use? Don't know, but you've got to know that. You've got to have an idea of that. Scoping it, and that's the BIM execution plan. We'll talk subsequent sessions on that as well, but at the end of the day, if you're going to BIM, know why you're going to do it. And if it's to do every single possible BIM use, well, hopefully we know what we're going to do. If it's simply to just make our drawings, equally, hopefully we know what we're going to do. So the BIM execution plan, there's templates. We can make it. It can be informal. It can be formal. It just has to be there. You have to plan what you're going to do. Resources, obviously, are important. If we're going to do the work, we've got to do it right. Have the people. The project BIM lead, there's going to be a course specifically on it alone. And that's your point of accountability for all things BIM/CAD on a project. And I stress, they're not the point of they know everything, but they're the focal point where they can go and find information, help make things happen, find out if there's any issues, ensure that the BIM goals are being met, ensure that we're not increasing scope, all that good stuff. The leadership. So it's always important to have buy-in and understanding at the corporate level. So if there is training requirements, maybe hardware requirements, maybe changes of approaches and workflow, we do have buy-in from top down, bottom up, all good, we're all on the same page. And then lastly, collaboration. We've got to speak. We've got to be able to each other, whether it's in an online cloud environment and on our servers, within our office, people to people, video conference, client to designer, whatever the case is. Another aspect of BIM is the dimensions. So 3D, 4D, 5D, 6D, 7D. I've seen many different interpretations of the dimension beyond 4D, but I like showing it this way where, you got to charter your team, plan what you're doing. Those are your first two dimensions, if you will, of BIM. Then your BIM model, there's your 3D. It's your intelligent parametric model using the authoring tools that was prescribed in the execution plan, and you're achieving design-specific goals and getting ready for beyond design. Then when you hear 4D, 5D, 6D, 7D, and it goes on and on and on, I like this slide because it's a potential never-ending vortex of dimensions, because that's what BIM is. You can turn on purposes and goals in order to achieve various results. 4D schedule simulation is the most typical term. So the 4D term is typically for scheduling the dimension of time. Then there's cost, viz, lifecycle. There could be sustainability. I've seen a whole host of different ones going down the vortex. So keep that in mind. And then it's understanding, where do you sit on the life cycle of the asset that you're modeling? So I use that term. There'll be an asset management course later on. But that concept that, let's say we're just doing a design project. It's good to understand that. But it's good to also understand that anything that we're modeling, it's an asset. It's going to be built. It's going to have a life cycle. It's going to potentially be removed or renovated. It's going to potentially die. And it's going to fit within this cycle. That's what the asset information life cycle is. So from our perspectives, when you're on a design, build, operate project, you're touching each and every one of these. If you're just on a design bid, then there's interface between what we're doing on design to what a contractor is doing to what an owner is interested in seeing. And those three facets, although we are unique entities, we all have to work together in some form or another, because this is what happens to the asset and the information. And then when you think about it, I've been on projects where we've done a design, it's been built, and then we won the renovation of that design a decade later. So when you're in that sort of situation, the more up-to-date the representation of the most current data and assets are, be it the BIM model or data associated to the model, the better positioned you would be in order to achieve a renovation project going into design again. So that first part, I tried to be as software neutral as possible. The idea there was to ensure that BIM is not about software. If anybody who says BIM is Revit, Revit is BIM, Revit is just a authoring tool to achieve BIM in the building side. Software, there's usually broken up into three pieces, and this is evident in how our vendors perceive their software. So when you break it up into building, civil, and plant, there's uniqueness to the software that exists within those realms. Now, on the green text there are the various tools that we have. And in my history, I've been on many projects where you've had any combination of 2 or 3 or more tools in order to service the specific requirements of a project. Now, in IBI, our building tool is Revit, and we've been exposed to some of the other ones, and we have a lot of Civil 3D use throughout the firm, and we're looking at what the best plant modeling tool is. The reason they're broken up into this manner is because the exchange of models and information is very, there's a lot of industry work being done to say, let me go from Revit to ArchiCAD to EcoSim to Vectorworks. But going from Revit to OpenPlant or SmartPlant and crossing the building to the plant, it's not quite there in the industry yet. Especially, you may get graphics, but not data. So there's very specific things that occur in each one of those realms. And we'll have, again, a subsequent course looking at specifically at the software. The point is, once you know your software, so we have a project, it's a building, it's going to be sitting on a site. So we're going to have building and site tools. Which ones are they? How do they work together? Wrap around whatever platforms required. Do we have a CAD requirement for delivery, or is it just the BIM model? Make sure we have the right hardware, and then understand where is the information going and what is going there. And that's where, for me, the fun is. What do our owners actually want? Do they want CAD files and PDFs? Do they want BIM models? Do they want just data? And any one of those are answers that are all valuable. Now, just data, I wanted to just raise this here. There are a lot of owners that are explicitly requiring a simple data turnover, irrespective of software. So we have two standards. There's plant data exchange, ISO 15926, and building data exchange, ISO 16793. And 16793 is where you might have heard the term IFC, or Industry Foundation Classes. So those are two standards that are built, one to bridge the plant tools or bridge the building tools, and owners are understanding that and saying that they can accept information pertaining or governed by those standards. So if I'm in Revit, for example, export to IFC, I get this IFC file, turn it over, that can be taken in by an owner if that's what they're prescribing. Another standard out there is COBE, Construction Operations Building Information Exchange. Its concept there is to take a BIM model, apply the information to a COBE spreadsheet template, and then that allows that information to be imported into asset management or facility operation tools. Pretty cool, works pretty well with some of our building apps and some civil as well. Driven heavily by the US Army Corps of Engineers and the UK BIM Task Group as well. So there's a lot of traction there. And then lastly, I've done a lot of work with this organization called FIATech, Fully Integrated and Automated Technologies. And they focus specifically on interoperability within BIM so that construction and operations can take information harnessed from design applications and utilize them for specific BIM purposes. So there's a lot of effort there focusing on data itself. I've got an interoperability vision, and I've been on projects that have had this, where there's my BIM blob again, and you can have people from all over the globe feeding the information, using different vendors, and you can take all that information and portray it to a stakeholder. That's, the ideal world. We're not there yet, right? And anybody who's been on a multi-platform project, you've seen the challenges to make your Revit talk to Civil 3D nicely, let alone Revit talk to Bentley, or if ArchiCAD's in the mix, or it will get there, and it will become more seamless. But hopefully within our lifetimes, but it will happen one day. Next, it's a little blurb on collaboration. There'll be a whole unit just on collaboration itself. But the trick here is you want to make content, manage it, and deliver it. And the delivery of the information is so important because it's got to be the right stuff to the right audience in the right form. So often we get caught with doing more when we don't have to, or not doing enough because we didn't know we had to. And that delivery is critical to the success of BIM. And when you look from a project delivery perspective, if you have those three rights understood, you're most likely going to meet your project scope, schedule, and budget because it's all been planned for, scoped out properly, budgeted properly, and you delivered it. Once you've done that, we want to preserve the good stuff we've done. So any of the content creators on our Revit projects, hopefully we're getting all that content, putting our arms around it so that we can actually harness it and utilize it so you don't have to start from scratch on the next project. And through all of that, we need to collaborate. We need to be talking. We need to be sharing. Very critical piece. Now, from a collaboration perspective, I like to break it down to 4 steps. There's no wrong solution on how to collaborate as long as it's working. So part of my role is to try to rationalize the ways to do it. So what's being shared? We've got to answer that question first. What are we trying to collaborate from a BIM perspective? How many offices and how many entities? Very, very critical question. Am I sharing with the person beside me, or am I sharing with our office on the other side of the world, or am I sharing with an external entity that I don't know where any of their offices are? Who's accountable? So if we have a collaboration system, who's leading it? And that's partly built into this project BIM lead role. And then have we planned it? Let's design the solution and make it happen. So here we've got office to office, so for what's being shared, office to office versus in the cloud, is all the decisions are influenced by the type of sharing that has to occur. Is project A doing a Revit model and project B doing a Civil 3D model? Is project A, B, and C all syncing to the same Revit model? Is project A doing a plant model, project B doing Civil 3D, and an external entity doing Revit? All viable? I don't know. We have to find that out. The more locations require more care. So if you have every single IBI office working on a project, we better design this collaboration solution very well so that we're all collaborating and empowered and working. Once you do that, somebody's got to lead this thing. Somebody's got to make sure it's happening. Somebody's got to help to get technical support. We have to know if there's any costs, schedule implication, any technical resources required, how to onboard our teams, workshops, all of that good stuff, and then ensure quality. So this slide, and this you can imagine why I need a whole IBIU course just on collaboration. This is like a brain dump of all the pieces of the puzzle that we sort of have active today and going to. So if you go around this cloud here, we're looking at how to harness cloud power in order to connect our internal and external teams simultaneously. We have ProjectWise in action. We have Revit Server in action. We have work happening on our local file servers. We're exploring Autodesk's A360, thinking about ways to do asset management, and we're looking at some of the tools that are available out there. And then looking at how to synchronize across projects, how to work with project controls, how to dashboard our projects during construction for transmittals and submittals and review cycles, etc. How to manage our deliverables. And that's both managing not only deliverables during design, but what about our shop drawings? What about our consequences of change orders and change directives that directly feed back into our BIM models, so that when we get to asset management, we have true and valid information. And then also the reality capture, huge, I have a slide on that later, to get out there into the world to understand what the actual built form is and have it in a format ready to be integrated with BIM, either to start a project or prove completion of a project. So there's a lot there with collaboration. So some of the things that we can do and that we shouldn't do. So I'm going to talk about one of our myths first. And that's the 3D model doesn't have everything. And this is something that I delivered to the Manitoba Association of Architects once. And it was using this wall detail as an example. When we model, you're not going to model the finite details. And think back to the initial slide when I talked about the schematics as well. If there's thousands of instruments in an industrial project, you're not going to model every single piece of them. Conduit is another good example. Sometimes there's a huge debate on the electrical side. Do we model every single conduit? And usually we rationalize it to, if I have 50, 20 conduits all together, that's going to require space and dedicated space, we'll model the collective. But if I have one or two conduits that are field routed and can go anywhere and we don't really care where it goes, I just need to know it has to go from point A to point B, because it can be routed anywhere in between. So it's wall section. Typically we have geometry, and that's roughly what you would see. Even I look at that and I dream up, well, I'd model it differently. I'd probably cut the wall from the sill, but whatever. This is an example. And then more information would be added to it. This would be the 2D line work that we wouldn't model the membrane, the shuttles, etc. And then the detail is completed with the information. Some of the biggest misconceptions when BIM started was the belief that we're going to model the wall, stick in the window, press the Make My Drawings button, and my drawings appear, finished. And that's a big misconception. So I wanted to really, really stress that here, in that the process of achieving the drawings and schedule portion of the BIM use is very critical, in that we can model the bases, but there's still work to be done to achieve the quality deliverable that's required for architects and engineers in order to apply their professional skills. And we're working towards workflows, towards rationalizing them, to get the right training, to help our users to understand what are the best and most efficient means to get here, but you still have to get here. Level of detail. This is another one, and I call it the latest buzzword, and partially because it's used a lot in our contracts. Obtain LOD 300. Like, what does that actually mean? And how do you apply LOD? And how does that impact what we do or what we have done for however long we've been doing it? So the LOD specification, most of the images are from there. The one on the top left is from the AEC UK BIM protocols. So the idea here, when we look at the LOD specifically, 100 to 400, 100 is more just like schematic massing. 200 starts to lay out the location, the space. And 300 is, I'll term it, what we need to make our contract documents. And that's kind of the level, the braking force there, where we say to our either our contractor partners, when we're on P3s, this is always the dialogue. As designers, that's what we do. When we get to 350, it's more of how it's to be fabricated or procured, and then 400 of how it was constructed. And if you look at the example there with the connection details, this I've had a lot of dialogue with structural where, we can specify sizes of main members, and we can have non-graphical information associated to the model, outlining the materials, connections, etc. When you get to 350, all of a sudden you have actual elevations, actual members, actual connections. And that's a big break there. Engineers won't design the actual connections because they have to be designed, they have to be shop drawings, fabricated, and installed. And that's the big difference there. That people will say we've got to make sure we stress that, draw that line in the sand there. That the contractor still has to do their job, and the architect and engineer still has to do their job. And just because we're doing BIM, that doesn't mean, well, we might as well do 350 because we have a model, so what's a little bit more information? That little bit more information could be catastrophic with respect to liability, with respect to what we're taking on, what we're starting to own, when in reality, we don't have to at all. From the other graph, and I like the grade 1, 2, 3, that example from the UK. I look at that from modeling a chair. All I need is grade 1. I don't need anything more than grade 1 because I'm going to say it's a chair. If I'm speccing the chair, the spec will tell me who my manufacturer or manufacturers could be. And that's it. It's done. But when we're looking, let's say we're doing visualizations, well, maybe grade 3 would be better because it'll look better in a visualization. Then you start to look at your BIM authoring tool to say, well, you know what? Grade 3 is going to require a little more processing power than grade 1, so it might slow the model down. So then it starts to make you think, well, if we're doing grade 3, maybe we'll put the chairs in their own model so we can turn it off easy and unload it. So it starts getting to all that dialogue and all of that just from how do I want to model that chair. So imagine that, it's a chair. Imagine that with every single component that could be on a project. So not trying to make BIM scary, but you've really got to have that concepts when you're thinking about this, because again, you can get into that trap of, is it a 5-leg chair, is it a 4-leg chair, did I do the casters right, did I do the curve on the armrest right? And at the end of the day, does it do anything for my architectural design? Well, not really, because it's a chair. It's going to be a chair. So that's the LOD concept. If you're working on contracts and you see commitment request for higher than LOD 300, wave the flag, call us in, we can have the dialogue. So some of the things we can do with BIM, there's a lot of work being done with the conceptual tools. So there's always been the question, how do I bridge concept into Revit or Civil 3D or any of the other BIM tools? And here's a great, a lot of work with InfraWorks and SketchUp and allowing for quick and immediate conceptual designs with better integration for downstream BIM. So that's happening a lot these days, and I know we've done some work, some InfraWorks work here in IBI, and it's pretty impressive to be able to take existing almost GIS data, so existing aerials or Google Earth or some other media, manipulate it, do a design, and then take that manipulation and turn it into the fundamental starting point of a civil 3D model. Same with SketchUp. Build a building, quick some push and pulls to find some components, and then we're getting better at linkages between those SketchUp models into the BIM tools as they stand today. Analytical solutions. I show this one here quickly for the sustainability, but there's so many potential analytical purposes. But LEED has done some work specifically with Autodesk, this PLM 360, to actually help to query the design models, offer in commissioning information, as well as other sourced project data, compile it all together and portray it in support of LEED certification. So it's just one other way to say, you know what, you have the information, why not use the pieces you need for the downstream purpose that you require? Laser scanning has come such a long way in the last, I'm going to say 5 years. On the left is how it started, and on the right is what you get today. So the level of, or I guess the level of quality with respect to the scans. Yes, there are large files, and working with them is a whole other question. But as a designer, I can get right into that scan on the right and do a design without remodeling the points as I found. So here's an example from Aviva. They're a plant design tool, and this is a plant model, so pumps, valves, pipe work, inside a laser scan space. So think about how powerful this is. If you've ever been on a project where the client says, can you BIM my space? And I've been on that. And you go into the facility and you start to determine, do we pull out tape measures, measure and start modeling? Do we call in the laser scans? And what will we result? When laser scanning is done properly, you could get this. And with this true 3D dimensional space, you can actually assign intelligence to collections of points. So that column with the fire extinguisher, I can actually say the 1 million points that make up the column, we'll call that a column. The 1 million points that make up the tank on the left, it'll get assigned its name. So it starts to actually take points that are forming content and apply intelligence to them so that they can be harnessed throughout the project. And then design within. When you cut your drawings, plan, section, elevation, etc., the point scan can be the backdrop or not. It doesn't matter. It's at your choice. So very powerful to quickly BIM my existing without spending hours and hours and days trying to do it. 3D printing, that's just a generic one. We actually have a 3D printer in our 55 St. Clair office, and these are some of the examples. 3D printing plus laser cutting to actually achieve a portrayal of a model as it stands. So they take the model from the BIM tool, they prep it for 3D printing or laser cutting, and these are some of the results that can come out. And this last image is the Viva Next bus, one of the bus terminals, and you could see the level of detail you can get into with respect to laser cutting, with 3D printing the components, laser cutting some of the connection pieces, and the assembly of the model in order to portray it to the stakeholders who usually are the clients. Augmented reality is something that is growing, I'll say a little slower in the BIM world than I thought it was going to. From the visualization perspective, you could have 3D holographic goggles that allow you to immerse yourself in the space, but this concept here is augmented reality via tablets, where you can actually geospatially locate your project, geospatially locate your models, and then through the tablet see where the content is going to be on site. So it's pretty, it's pretty powerful. There's a lot of factors that have to come into play in order for it to work properly. But the example in the top left there, imagine walking down the street to see where you intend to put your utility network relative to something that may already be existing. And the same on the bottom right. We have a building that's going to appear on site. This is what I see. You can imagine, though, why it's a little slower is how accurate is that, and how right is what you're seeing? And so there's a lot of questions from that perspective, but I think the technology has the potential. Holographic imagery is one that I think is a little exciting when we get there. So this is on a black tablet hologram, similar to the hologram that you have on your driver's license. And sure, you tilt it the right way, you can get a 3D representation of what you're trying to design. And that's exciting, but I kind of want to get here. This is from Avatar, and I remember when I watched that movie, I was fascinated with the fact that, look, they actually have a BIM, and they're pulling apart the model, and they're pointing to items within. And I said, that's what I want. I want the hologram to come out of my iPad and become something that's interactive. So we'll get there one day. What we can do very well is, with our mobile tablets, we can visualize our designs, measure, review, markup, etc. So there's a lot of good tools that are out there, and that's also probably the detriment, is that there's too many tools out there that one of our tasks is to try to rationalize what the best practices or workflows are. But I can take, so going around the images around, I can go into any space and just drive through like I would on a game controller. I can turn components off. So here I've turned off the wall and I've highlighted a louver. I can measure to see what the dimension is, and of course, I would never design to that dimension, but I have fat fingers, so that's what I clicked. And then I can select an object, so it's an overhead door, and it gives me the business data as pulled in from the BIM model itself. The other thing we can do is we can actually analyze the statuses of delivery of content on site. So I can actually take a collection of components and identify whether they've been delivered, on hold, in production, shipped, installed, and I can use it as a statusing mechanism in order to inform the status of construction. Now again, you have to preface that for whether it's part of our contract, whether I'm functioning as the contractor versus the designer, and where that fits within the scope of work. So always keep that in the backdrop, but there is some powerful things we can do with mobile applications. All of these are iPad examples, but for the most part, they're all also on Android as well. So overall, as I talk through what BIM is and what it can do, the stress is that, throughout the life cycle of the project, you can find benefits. And I think the important thing is, whatever is appearing on this screen here, it's only a small subset of some of the actual things that we can actually do with BIM. And I dare say there is no limit, but collaboration, planning, understanding why you're doing what you're doing, ensuring it fits within your project scope, schedule, and budget, you're enhancing quality, you're not creating risk, all of those things have to be taken into play. It's not just do BIM because we could BIM. That's not the reason why we would do BIM. And with that concludes the first session. The curriculum, this is what we have planned for the next 12 sessions. I did notice as we were starting here, apparently some people were locked out of this webinar, so I may offer this webinar again, but any one of these in any particular order is the ones that will be coming down the pipes. So keep an eye out for these future sessions, and what we'll do in all of these is get into a little more detail with some of the topics that were described, and just really explore more of the possibilities that BIM can bring, ensure that there's always that thought and alignment with project delivery, project management, and the needs of the project. So thank you, everybody. We do have some time for questions, so I'm wondering if anybody wants to type questions in. I don't see any questions in here. Oh, wait, there's a couple. Oh, sorry, there are questions. Let me see if I can access some of these questions. So, yeah, the presentation will be available. Definitely, the presentations, I should have mentioned that, will all be posted to IBI University. So upon completion of every session, I'll be posting the video into IBIU, and then the links will be made available. as well as for those who missed the session, they'll be able to access the session on their own time. Let me see the next question here. Okay, I think that's all the questions. If you want, let me see if I can quickly unmute. Yeah, let me try to unmute everybody. If there's any questions, feel free to throw them out there or type them in. Okay. Yeah, this might not work with the live questions. If you do have questions, if you want to just type them in, I'll give another couple seconds here, and if not, then we'll